Michigan, in April, we normally expect to get raindrops because the weather's pretty warm outside. But it's been unusually cold the last few days, and so we are seeing precipitation in Michigan in the form of snow today. Precipitation is any of that water falling back down to earth. It could be rain, it could be hail, it could be snow, and then it is collected back on the ground. That collection, we say, as the water kind of runs off back into our lakes, rivers, and ocean, we can either call that collection or percolation. Now, some of that water isn't collected into our lakes and rivers and oceans. Some of it is absorbed by the living things on our planet, including trees. So trees will drink up the water, and trees actually almost sweat, just like humans do, and they can actually transpire some of that water back up into the air. So all of these steps are happening either simultaneously or in order, and our water cycle is constantly flowing here on Earth. We'll dive deeper into some of these steps of our water cycle and talk about how they relate to weather. The first thing we'll talk about is how clouds form. We're actually going to make a cloud right here inside our distance learning studio using something other than water. Now, this activity we actually adapted from the NICE network. So the NICE network puts out all these kits of activities every year, which they call the Earth and Space Toolkit. They came out with this activity this year called Investigating Clouds, talking about how scientists, especially NASA, will study clouds in order to tell us about climate change here on Earth. We'll be posting the activity link from the NICE network in the description of this video following the program, and we'll post more resources from NICE network throughout the week as we celebrate Earth Day, which is tomorrow. If you're looking for more activities you can try at home, of course, as always, we have our website linked down here at the bottom. Our website, if you search for At Home Science, you can find a link to the Earth and Space Toolkit, as well as some other weather-related activities. So let's get started with creating our cloud. We'll create our cloud inside this large glass jar, which was almost hidden by my green screen, fancy enough. But before the program, I've poured in some isopropyl alcohol, and we'll add in just a little bit more. The reason that we use isopropyl alcohol instead of water to create this cloud is because isopropyl evaporates much more easily. We call it a volatile liquid, meaning to get it to evaporate, you don't need to change the temperature by very much. We can start that process just like we've done with our whoosh bottle in the past by swirling around the jug and just exciting some of those molecules inside. What we'll do next is we're going to increase the pressure, thus increasing the temperature inside the jug just by adding more air inside. So I have a balloon pump here with a rubber stopper on the end, and there is a hole in this rubber stopper so that I can plug the opening to our glass jar and add more molecules, more air molecules to the inside of this jug. There's a principle that we talk about using this, which we call the ideal gas law. It's written right here on the top of the slide, but basically what this tells us is that if we increase the pressure or the amount of molecules inside a container and keep everything else constant, our temperature inside will increase as well. You can think about that because the more molecules we add, right, the more friction we'll create, the more kinetic energy is going to be contained inside this jug. So adding more molecules adds more kinetic energy, thus resulting in a change in temperature, which makes the jug just warm enough that that isopropyl alcohol will start to evaporate, just like the first step of our water cycle that we talked about using that diagram. All right, so let's go ahead and pump some air into this jug. We'll try to pump it about 15 times, but the more air that we add inside, the more difficult it gets to force molecules inside. But let's try to give about 15 pumps of air, which should be enough to create a cloud in this bottle. Whew. All right. Now that my arm is nice and tired, let's go ahead and release the pressure, thus dropping the temperature inside this jug. And there we go. We've created a cloud. It's especially noticeable if I kind of move my lab coat so we have a darker background behind it, right? This is all because of those relationships between temperature and pressure, just like in our water cycle. Let's try that one more time. If we introduce air back into the jug, right, we'll increase the temperature inside. All right, so more of those molecules have evaporated. Our cloud has disappeared. And now let's go ahead and drop the temperature by releasing the pressure. Here it goes. And we've created a cloud again. Now, Nice Network does this experiment using some more simple materials. So instead of using our big glass jar, you can actually do the same experiment using a fizz keeper, which is this white cap that I have on the bottle here. This white cap, normally you can screw these caps onto the lid of your soft drinks, and then you can pump air inside, which will help your drink to stay carbonated even after you open it. So you can buy these caps at most grocery stores, or you could pretty easily order some of them online if you're looking for a way to recreate this experiment at home. Now, we said that we used isopropyl alcohol. I just happen to have 91% at my house, but you could use any strength isopropyl alcohol for this experiment. 50% works just as well. All you're really looking for is something that evaporates more easily than the water does. The only trick with this experiment is that these fizz keepers, they only move a very small amount of air in comparison to our balloon pump here. Also, since this plastic container is able to expand as we add air inside, you have to pump this about 100 times in order to get this experiment to work the same. But we'll go ahead and give it a try. Pump it as many times as I can until my arm gets really, really tired here. And again, what we're doing is just adding more molecules, thus more pressure inside the container, causing that isopropyl alcohol to evaporate. We can still see some in the bottom here, but some of it is starting to turn into a gas, which is the basis for our clouds. All right, very lastly, before we release the pressure inside, we can take our laser thermometer, which we used during our microwave it episode, and let's get a temperature reading here on our bottle. All right, our temperature reads about 75 degrees Fahrenheit, which is fairly warm. So let's go ahead and pump it maybe 10 more times, and then let's release the pressure. All right, here we go. 3, 2, 1. Ta-da! I actually got a much better cloud this time out of that. All right, let's take another temperature reading of our bottle here. Make sure we're getting just the bottle, not the reflection. And we've dropped the temperature. It's about 72 degrees now. We've dropped the temperature by 3 degrees, which is pretty significant when we're just talking about the amount of temperature drop needed in order to form the cloud inside this bottle. Now, if you follow along with that lesson plan that we'll post from the Nice Network, you'll learn a little bit more about how NASA astronauts actually use lasers like this one to study the effects of clouds on Earth's changing environment. So we can learn a lot from clouds by using lasers, by studying their thicknesses and their temperatures. And there's more information, again, on that in that Nice Network lesson. So pretty easy to recreate at home. These fizz keepers are very, very inexpensive. And you can use them afterwards for household things other than just science. So we'll go ahead and we'll set this experiment off to the side. And let's talk a little bit next about convection currents. Now, if you've ever watched the news, they do a lot of talking about hot fronts and cold fronts, or high pressure and low pressure zones. We did an experiment with hot and cold and pressure using our cloud in the bottle, but let's dive a little bit deeper. So you might hear the weather people talk about how hot and cold fronts move across the country, and sometimes they'll meet together, which can result in storms. We're going to represent our atmosphere using this clear jar of water. Now, the water in this jar right now is about room temperature. So the water in this jug, or in this large beaker here, That is room temperature water, which will represent our atmosphere. What we're going to do is we're going to add a hot front and a cold front, being represented by hot and cold water, into that container. So like if you were looking at the sink, our cold water is blue. So we'll fill one film canister here with blue, pretty cold refrigerator temperature water. Fill that almost all the way to the top. All right, and then we'll put some just microwaved warm water into the other film canister here. So we said that these will represent our hot and cold fronts of air that travel across the land. Now, tell me what you think is going to happen to the hot and cold water if I were to drop them into this container of room temperature water. Think about what might happen. Remember that red is hot, blue is cold. Tell me what you think might happen to these fronts as I drop them inside. I'm going to cover them up, and we'll uncover them once they're inside the liquid, just so that we don't contaminate our experiment here. But I'm just going to cover them very quickly. And again, we'll remove these once we drop them inside. But use the chat feature either on Zoom or on YouTube or on Facebook and tell me what is going to happen to our two fronts once we drop them inside the beaker of room temperature water. Zoe in Zoom tells me that the water would change colors. So if you're an artist or you're familiar with your colors, you might know what color we get if we mix red and blue. So maybe that's a good guess of one hypothesis maybe of what might happen. Any other guesses? Let's see. I see that Cameron tells me that blue might sink while red might float. So if you remember back to our density or sink or float episode of Echo Live, you might be onto something there. Someone tells me that their temperatures could change, right? So we know that that the world works in terms of diffusion, that things that are either very, very hot or very, very cold will kind of want to equal back out to the middle ground. That's another great hypothesis. All right, let's go ahead and drop our film canisters inside. Now I've weighted them down with pennies before the program, only so that they both start at the bottom of the container. But now let's release the contents of our film canisters here. Let's release them and see what happens just by poking a hole in the top of each container. And what we're looking for is what happens to the red and what happens to the blue front. So remember that the red represents a hot front, an area of hot air, and the blue represents a cold front, an area of cold air. So we can already see some results are starting to form. Our red water, that hot water, is traveling up. If you think back to our density experiment, right? Those molecules in the hot water have a lot more energy. Therefore, they're much more spread out. They take up more space, which makes them less dense than the room temperature water. And so they're traveling up towards the top. Let's poke a bigger hole in our blue here because they're pretty content. The blue molecules, since they're really, really dense and really cold, they'll want to stay at the bottom, which can also cause them to stay inside their film canister here. Let's see if we can get it to tip on its side. It doesn't want to. But we can see that the blue water stays well below the red water, right? So blue water or cold air is much more dense and it wants to be closer to Earth's surface. So that blue water travels downward, whereas our red water is warm and it always wants to rise up into the atmosphere. But what would happen if our hot and cold front met each other on the wrong side? What if a hot and cold front traveled across the land and met, but for some reason, the cold air was on top of the hot air? What would have to happen? Think about our density experiment. Think about what we did if you were present for our sink or float episode. Think about what happened to our water in our two vases or our two cups when we stacked them on top of each other, depending on their temperature. Yeah, tornadoes could happen, right? I'm hearing some great answers that we could get some extreme weather, right? The air has no choice. The cold air has to sink down to the bottom. If a hot front were to get underneath it, right, those two fronts of air would rush past each other very, very quickly. As they do that, right, the air could become very, very windy, maybe even so windy that we get something like a tornado. If this were to happen over water, right, we could also get a hurricane. So this process of convection, this process where hot air will always rise and cool air will always sink, can give us those forms of extreme weather here on Earth and on other planets as well. And that's all to do with density. So if you didn't get a chance to watch our Sink or Float episode of ECHO, if you're interested in learning more about density and why this process happens, make sure you go back. Those are posted on our Facebook and our YouTube channel. You can go ahead and you can check those out. Now, before we get to our very last activity, I'd love to pause and see if you have any questions about the activities that we've done so far. We've got a whole week of Earth Day activities or Earth and space related activities planned here on ECHO Live. So we'll be talking more about science behind weather, behind our atmosphere, behind Earth and space sciences throughout the rest of the week in celebration of Earth Day, which is happening tomorrow. So if you do have questions, go ahead and type those in the chat now. We as always want to thank our sponsors like Denso, who allow us to bring these programs to you for free at home every weekday at 2:30 p.m. Eastern. We love that we see so many of you tuning in every day, watching our ECHO Live programs, asking great questions, and even suggesting some demonstrations that you want us to try. So if you have science topics or experiments that you'd like to see us try here on the air, make sure you send them to us. Either tell us in the chat, send us an email, send us a message on Facebook, and we'd love to do those experiments for you live. If you'd like to be alerted when we do go live every day, make sure you are following the Michigan Science Center on Facebook or subscribed to our YouTube channel. And then, like we said, we'll see you back here tomorrow at 2:30 for more Earth Day planning and every weekday after that. So we do, let's see. No questions yet in Zoom. If you've got them, go ahead and type them in the chat. Let's check on Facebook. Someone asks, can you use a can for this experiment? You could. You really want a clear container so that you can see the water moving inside our convection current. If you're looking for alternatives for things you could use instead of film canisters, I really like to use those little condiment cups, the plastic condiment cups that have the lids. You can take the lid right off and cover it with tin foil or saran wrap. You could even substitute our cold blue water with a blue dyed ice cube that you could make it an ice tray in your freezer. So if you're looking for ways to try these experiments at home, make sure you're checking on the Michigan Science Center's website. We post guides for all of our try this at home science, and we'll definitely help you through those. There's some suggestions for other materials you can use in those experiments as well. Love that we're getting some suggestions. Keep sending those. I am seeing them, and I'll make sure that we get some activities planned about. I see requests for slime. I see requests for flowers. We can definitely cover both of those topics on ECHO Live. All right. So let's do our last weather-related experiment. If you still have questions, keep typing those in the chat. We'll keep checking on those, and we'll maybe have a chance to answer just a couple more at the very end of our program here. Now, this one has to do with precipitation. So this is, again, an experiment that you can try at home using only a couple really easy materials. We've got water in a clear cup. It's important that this cup is clear. We also have some food coloring that I've dyed with, or we have some water that I've dyed with blue food coloring. I have what's called a pipette, which is just a way to transfer water from one container to another. But you don't necessarily need to have a pipette. You could use a straw and just plug the end with your finger. You could use a turkey baster. You could just drip the water in very slowly. So you don't necessarily need a pipette to do this experiment. And then lastly, you just need some shaving cream in order to create a cloud on top of your water. All right, so we've got a cloud. We'll try to make sure we've covered our entire surface here. And what we're going to be doing is adding water molecules with our pipette to the cloud until we see precipitation start to happen. So let's really zoom in on the glass here. There we go. And we'll just slowly start to drip water onto our cloud. We said that as more water evaporates off of Earth's surface, that water starts to collect in these clouds. Now, clouds are formed because there's not just air in our atmosphere. There's also things like dust or pollen. There's other things that those molecules can attach to in order to form clouds. These clouds and that dust or any other sort of particle will continue to collect water until the weight of the cloud becomes too much to handle. At that point, we'll start to see precipitation. Now, it's important to be patient with this experiment. You want to add your water just a few drops at a time rather than trying to shoot a jet of water through your cloud, because that isn't necessarily what happens in nature. But as I'm adding the water, I can start to see some of it is precipitating. There we go. We've had our first drop of water almost puncture through the bottom of our cloud right there in the front. If we continue adding, right, this precipitation has to form. This cloud needs to drop that water down back to Earth's surface to be collected in our lakes, rivers, and oceans. So if you look at the bottom of our cloud there, we are starting to have precipitation. We said precipitation is rain, snow, sleet, hail, right? And that water is important because we need it to be collected back down on Earth's surface so that we can use it, so that it can water our plants, so that people can drink it, so animals can drink it, and so we can use it for other things that humans need to survive. All right, so we'll just let that keep precipitating there. And that is our last experiment of the day here on Echo Live. Like we said, we've got a very special plan for tomorrow's Echo Live, all about Earth Day tomorrow. April 22nd is the 50th anniversary of Earth Day. So we'll be talking all about climate change and what we can do to be good stewards of the Earth. Now, someone asked, very last question, does paint work for dye? Yes, if you find you can either use watercolors on paint, something that can be dissolved in water. You could use that for this shaving cream experiment or for our convection current experiment as well. So thank you so much for joining us for another episode of Echo Live. We hope we'll see you back here tomorrow in celebration of Earth Day and in celebration of planet Earth itself. So have a great rest of your day, everyone, and we'll see you tomorrow.